Okay, so I think I hope everybody is back and listening. So I think we will now get into um, a bit of a discussion on the domain 5 and domain 6. So these two domains are essentially the longest amongst all the other domains in CCSP, which is cloud security operations, and the next one is being about privacy and legal and compliance issues within cloud. But those are the longest, so that's why I try to give more time to it as we go through it, especially for domain 5, which is cloud security operations. But you should definitely plan yourself in a way that you have enough time at hand to go through this domain. So when you look at this domain, cloud security operations, it's a mix of old and new practices, along with the shared responsibility structure that the cloud model professes. So there's a lot that gets covered here, and move ahead. We'll talk about each of them. It talks about how do you build and implement the infrastructure for cloud. Then it talks about the whole set about how you operate and maintain that infrastructure. Then it talks about the operational controls and standards. For example, how do you do all of your ITSM processes of incident management, problem management, change management, security management, etc. in that cloud. Then it goes a bit into how would you do digital forensics in cloud, because cloud does not give access to everything, but in a situation of an investigation, how will you make it happen? And some aspects about when you're running security operations in cloud or operations in general in cloud, who are the relevant parties? How do you communicate? Because cloud creates a distributed architecture. Not everybody is located in the same location and the same time zone. How do you work in that model is what it touches upon. And then how do you manage some of the key aspects of security operations like logging and incident response, etc. So, So implementing and building the physical and logical infrastructure for cloud is typically a cloud service provider side activity. It is all about how do you build this infrastructure that controls the risk that's related to the multi-tenant architecture, ensuring that there is appropriate capacity and redundancy and resiliencies to ensure that the services are always available to all the tenants of the cloud service provider. It also talks about the virtual private cloud or the VPC or such logical aspects which the customer can configure. The cloud service provider gives you those capabilities, and then it's left to the customer to utilize and use those capabilities in their setup. So here the targets are typically the BIOS, which is critical for secure booting operations. It is important that the service provider is able to secure the BIOS because it checks for the integrity of hardware and firmware, which if fails, can be tricked to accept malicious hardware and firmware. And there is a guidance by the NIST, which is a special publication 800-147B, which talks about controls related to BIOS security. The next piece, because if you see, this is very much at the hardware level, this is at the CSP level, right? We're talking about BIOS, we're talking about the next one, which is Trusted Platform Module, or the TPM. So again, it's a dedicated module which is included in the computing system, and it has some specialized capabilities which will help the system perform certain cryptographic functions. So it has a persistent storage, and then it has a dedicated processor of its own, and then it has a volatile memory to perform certain cryptographic functions. So it can store the crypto keys which are used for disk encryption, It can store the system component hash, which the BIOS can then check as part of its integrity checks. Again, in TPM context, they come in different form factors. So you could have a dedicated hardware, and then there could be an embedded integrated firmware TPMs, and then you have virtual TPMs. And all these form factors are in the decreasing ability to tamper resistance. So if it's a dedicated hardware, it's more resistant to tampering or evidence against tampering. If it's integrated firmware, it is lesser. If it is virtual, it's even less. Virtual TPMs are part of the hypervisors and are provided to virtual machines. So the same TPM concept would be available if you're using virtual machines, but then you're using a virtual TPM in that sense. There are storage controllers, which is nothing but which controls access to the storage devices. It provides the interface to the applications or users to those storage devices. Network configuration is something which most of the large part of it is the CSP or the cloud service provider who manages the hardware. The customer manages the virtual aspects of as they design their cloud data center, for example. So they can use concepts like software-defined network, virtual private cloud, so on and so forth. So we'll talk about it, or more if you get time about those things. But those are covered as part of this domain. Then we come to the installation and configuration of virtualized management tools. So which is essentially some of the this basically consists of the virtualization platforms and management consoles, which are nothing but a single point of failure for all virtual machines that are running on top of it. And therefore, the security or secure design of these virtualization management tools is pretty important. And for that, it recommends usage of best practices like in hardening standards like CIS benchmarks. There is DSA STIGs, which is from the US federal standpoint. So there are concerns which are basically relevant to the virtual management tools about redundancy. How do you make sure that it doesn't serve as a single point of failure for all the virtual machines from different tenants running at this layer? There is also scheduled downtime and maintenance aspects, because at some point you would have to take that or upgrade or put patches or upgrade that virtualization layer. How do you make sure that the VMs that are running on that layer are still available? So concept of VM migration during those periods comes into play. And there are isolated network and robust controls, configuration management and change management, logging and monitoring, which are standard set of controls that you would expect to be applied to any IT system as such. Just that it stresses on the importance of how important this particular component is, because a lot of virtualization, virtual machines, and everything above that is running at this layer, and therefore the security and availability of this becomes paramount. So virtual hardware, which again would be the virtual machines. So the biggest issue again from a multi-net tenancy standpoint is always about enforcement of strict segregation between the guest operating system, which is the virtual machine, which is running on a single host. So there could be so many VMs running on a single host. How do you ensure that there is a segregation enforced between those different machines or different VMs? Again, at the hypervisor level, which is the single point interacting here, we talk about secure configuration and patching. I touched upon it in the previous slide. And virtual hardware, which is highly configurable. So you would have those virtual machines. You could create those VMs in a hardened state or as per your organizational and industry best practices. For example, you have that option, but again, it's the responsibility of the customer leverage those features. So if you don't, and you keep your VMs without following any kind of a hardening process that works for your organization, then you're not doing justice in your shared responsibility model. In the virtual network concept, you have virtual private clouds, which we talked about a bit in the previous session, I believe, last Saturday. VPC is nothing but the same concept of running a private cloud in a public cloud setup, right? So you get the a virtually isolated network segment within the broader public cloud space. So what that is VPC. There is security groups that are introduced, which are nothing but equivalent of access control lists that we usually are familiar with. And then we talk about other concerns regarding over provisioning. We talk about VM sprawling, how much of an issue that is if that's not controlled by proper governance processes. Infrastructure as a code is a unique aspect within cloud, because a lot of these days developers can deploy infrastructure as a code using definition files along with their application code, right? So in the whole dev ops culture, serverless culture, it kind of becomes more important, because it gets very important for the developers to be trained on aspects of deploying infrastructure as a code as well. They should be aware of not just the best practices in application coding and software development, but ensuring that the definition files that are being used for infrastructure as a code are also compliant, secure, and they are as per industry standards, or because it's the same coding practices that would come into play there. There is also a lot of tool sets that are typically provided to enhance or provide specific capabilities, which are called as virtualization tools that the CSP provides to the guest operating system. Like you want support for additional devices or driver software on your VM, then the CSP can provide you certain additional tool sets. But it should be understood that the more you put in your environment, the more you expose your environment to vulnerabilities and defects. So it's always recommended that minimum necessary functionality is practiced, and you should avoid such tool sets unless they are really needed. Again, operating the physical and logical infrastructure mostly lies within the cloud service provider. And some of these things that you would see here are pretty standard as well. You would have your, since the cloud typically is accessed remotely, more from an administration purpose as well, one needs to be familiar with the secure remote administration protocols like the SSH, RDP, VNC, and things like that, because even the cloud service provider administration would mostly happen remotely than locally, because they are spread across globally. The next thing about KVM switches, you must have heard about it: secure keyboard, video mouse. This is introduced in this section. I won't go into it much, but it's more of a secure hardware that is used to connect to multiple servers or system components from a single unit, right? So there's KVM was always known. What is a secure KVM? So that it cannot be compromised. Some of the controls that are related to secure KVM are mentioned there. We should also there should be restricted access to the admin console, both the admin console that the CSP uses and what the customer uses, because from an admin console you can obviously launch and configure things, and therefore that should be restricted. and then there's a lot that is introduced. So this domain actually goes into a lot of technical aspects from the infrastructure standpoint, and therefore it's one of the most, as I said in the beginning, a very lengthy domain that you would cover in the CCSP itself. In the secure network configuration, there's a lot of these standard protocols which we all would be hopefully familiar about: VLANs, TLS, DHCP, DNS, what are different types of DNS attacks. It talks about VPN, some common used VPN protocols, and then the software-defined perimeter. So software-defined perimeter is nothing but, since there is no physical perimeter anymore with the use of cloud, you use a software-defined perimeter concept where you have a central SDP or software-defined perimeter controller, or SDP controller. That controller then uses to centrally authenticate and validate hosts that can talk to each other. So maybe I'll have a slide which kind of depicts what this is about. So yeah, so this is what all it covers when it comes to the operating part of the physical and logical infrastructure. This is the KVM that I was talking about. I think it should be, we covered this. We also should understand how the TLS or the SSL handshake happens. What are the different steps involved between the client and the server? How this uses the asymmetric key encryption, and then for each session you create session key. So that whole process, I think you should definitely go through separately and understand a bit more. So this goes into all of that as such. So again, I mean, there's a lot of here, DHCP, what is that process? In DNS, how can you do, how can DNS be attacked, and what type of controls you need to have in place gets covered there. So yeah, now coming to the, continuing with that particular topic here, we have, we talk about the hardening through application of baselines. So baselines, as we had some questions done in the past, are nothing but a documented standard, a documented and standard state of an information system. So what it basically means, it should, any instance of hardware or infrastructure that is deployed will always follow the same configuration pattern or same configuration protocol. So documenting that as a baseline becomes important. It can be achieved in many different ways. You can have a customer-defined VM image where the customer creates from scratch. Cloud service providers also provide, baseline image based on their understanding of how one should be secure. There is DISA, there is NIST, there is CIS, and you can use a combination of all of this. For example, you can have a CIS benchmark as your starting point, and then you customize it based on your business requirements. So you can use combination of these different ways to come up with your baseline. These baselines again are important because when you're using infrastructure as a service and you're launching virtual machines, those virtual machines should then adopt these baselines so that your environment is always following a certain standard. Now, there is a concept of standalone hosts, which are basically, the cloud service provider says that there are concerns related to multi-tenancy. So we will provide standalone hosts, which basically means there is no, at the hardware level, really you have dedicated setup. So that's what standalone host means, that you're using single hardware for a single client or a single customer. But at some layer, there is always a shared concept, because even if you're using a single hardware dedicated, your underlying physical premise or your core network setup is still shared. So at some point, there will always be a shared concept. It's just that you would have to accept that risk if you're going with this standalone host. Obviously, it's much secure than running on a pure multi-tenant architecture. There is also introduction of clustered hosts. Clusters are nothing but grouping of resources with some coordinating element. I think you can have some fashion of grouping of clusters of resources such as processing, storage, network traffic, handling, etc. The mediating access to shared resources in a cluster include reservations, limits, and shares. So these are some of the concepts that are introduced that you need to aware what is a reservation, what is a limit, and what is a share. So a reservation is really about you put in a static value of you will always require this much capacity or this much resources, and the cloud service provider will ensure that that capacity is always available to you upfront. Obviously, you get some discounts as well because you have pre-committed a certain level of usage. Limits is basically on the other extent to say you would never go beyond a certain level, and this comes into play when you're trying to put some management controls on, let's say, the amount of usage that your cloud consumers in your organization are exhausting. And shares is more of a weightage which is given to a particular virtual machine that is used to calculate the percentage-based access to pool resources when there is contention. So those are some of the concepts which would be helpful to understand when we talk about the infrastructure in the cloud. I think some of the other concepts here, there's too much here, but I think there's another concept here which is about availability of, or rather high availability versus uptime that you see there. So it needs to, it clarifies what's the difference between a high availability and uptime. Right? So uptime is the amount of time the system is running, that's all it says. High availability is ensuring that the system is not just up, but available and usable. For example, the system may be available, or the VM may be running 24 hours, but if you don't have the network availability to reach that particular virtual machine and use that virtual machine, it's not available to you. So that's the distinction we need to make between what is high availability versus uptime. And then we also need to understand uptime institute 3 tiers. So there is tier 1, tier 2, tier 3 of how to design high availability data centers. So those all things are getting discussed here. There's a lot there. Again, I will move on so that you can cover more concepts, or what are we trying to cover in this domain. This is what I was talking about, the 4 tiers architecture for data center design that is mentioned as per the Uptime Institute. It's important to spend some time here because there are certain questions which talks about data center design, physical data center design as well, which is, so basically when you do the CCSP, when you do go through the questions, you will see at least from the preparation standpoint that they do cover aspects of secure physical data center design as well. Not so much because it's more of a CSP specific aspect, but it's good to go through some of these. So this is the details about what's a tier 1, tier 2, tier 3, tier 4 data center. And then let's come to the managed part. We talked about the remote access and the controls that you would need to ensure that the remote access is secure. Operating system baseline, compliance monitoring and remediation. We talked about baseline, but then you need to have a management process in place that would monitor and remediate any deviation to the baseline. And it uses CMDB. We need to do vulnerability scanning. There's also a concept of immutable architectures. Immutable architectures mean that you cannot change the virtual machine after deployment. You just retire and commission new known good state. So usually for short-lived instances, immutable architecture, as the name says, once it's provisioned, you are not allowed, or you cannot change that, so that there is no baseline deviations. You always can deploy the next machine using the same baseline or the revised baseline. So in certain use cases, it makes sense to use that architecture. Again, as I said, for short-lived instances, it might be better suited to use immutable architectures. Patch management as a concept applies, again, it depends which cloud service model you're using and to what extent you as a customer are responsible for patching. And again, the patch management process, which is described in this section, is standard process, so I'll not go into it so much. So I think on the, not so much on the patch management as such, but again, just to touch upon the software composition analysis. Software composition analysis is about the checks that you use to identify vulnerabilities in applications that are built using open source software components. So this is just a concept introduced under the umbrella of patch management, because this is one of the evolving practices when people adopt cloud architectures. They want to use or reuse components that have already been built in the past. So that's where it gets introduced. So I just want to touch upon it a bit. All right. Continuing on the managed part, there is performance and capacity monitoring. Which is monitoring by the cloud service provider is critical, not just for security reasons, but also for ensuring that there is enough capacity to meet the needs of all the customers and tenants that it serves to. So how do you do that? How do you make sure that you are efficient and effective in running this capacity planning process? So monitoring becomes an important part of it. And even more important is the billing process, right? How do you bill back to the customers for what they have used? Well, monitoring has to come into play there as well. And different things that get monitors are network, compute, storage, and hardware, storage and memory, sorry. In hardware monitoring, you would basically target the compute hardware and the supporting infra, which is monitored for fault monitoring. So, you know, or sometimes even before there is a fault, you get notified as a cloud service provider that a component is going to fail and I need to take proactive actions, or it can be auto-remediated. So some of those technologies and aspects are discussed there. And environmental monitoring is basically your HVAC monitoring, ensuring that there is enough humidity, there is your temperature is maintained, and all that stuff comes there. Configuration of guest and host operating system, backup and restore functions. So here, the responsibilities between the cloud service provider and the consumer varies depending on the service model they're using in terms of what layer they are responsible for the backup and restoration. So if it's SaaS, you pretty much have none. But if it is platform as a service, you're pretty much responsible for the backup of your you're responsible for the backup of the data or the application you use using that platform as a service. And if it's an infrastructure as a service, you pretty much are responsible for the entire the virtual infrastructure or the operating system and the anything, the software and the data above it that you have created. So again, the shared responsibility model comes into play in terms of what is your responsibility when it comes to backup and restore functions there. I think some of the topics would be a repeat. It just gets reiterated when these domains get covered. Like for example, here you're again discussing about when you store backups, what are the considerations you need to use? You know, the backups have sensitive data in them, so it needs to be stored with the same sensitivity. You should not allow snapshots or backups to be created on the same physical hardware that is running the VMs, because you have a single point of failure, and you need to be able to verify the integrity of the backups on a periodic basis. So these are fundamental security considerations when it comes to backups, which apply in the cloud scenario as well. Um, in the network space, we introduce a lot of concepts again in this, which are not necessarily only cloud specific, but it covers all the different types of technologies and concepts when it comes to network security controls. So one major concern related to the ability of some tools to function the cloud paradigm is essentially the fact that some of the traditional protocols may not apply in a cloud paradigm, which, for example, VLANs, right? So VLANs is a layer 2 concept, but how do you get the VLAN concept in a cloud when you're running a virtual private cloud? So those adoptions of the same concept in a different layer, layer 4 and above, for example, is talked about like VXLAN, virtual extensible VLAN is the equivalent of VLAN when you use it in a cloud as a cloud consumer is talked there. So those are some of the also the second one would be how do you do let's say network sniffing of the traffic, because in a VM to VM communication, it doesn't really go through the network layer, it's only at the hypervisor layer. So adopting that concept at the VM layer level is what comes into play as well. So those are some of the concepts that have been created or patented, let's say, to enable the same benefits of a VLAN, network tapping, etc., etc., but in a different setup where you may not have access to let's say, the layer 2 as a cloud customer. The one thing which I would call here is about when they talk about honeypots and honeynets, we understand what they are. What something to keep in mind is we should not be setting up the honeypots and honeynets in a way that encourages entrapment. So although people set up honeypots to study and see how the external traffic is behaving, what type of malware attacks are happening, and then learn from it. If you limit it to just that, it's fine. But if you're trying to use that as a way or means to lure or induce people to come there and do things and then take them to court for that, is something which is considered illegal in many parts. So honeypots should be not set up in a way that entraps or induces somebody to come and act on it. If that is the situation, then you may not have a legal basis. So that's something to call out when we talk about honeypots and honeynets. Another call out would be in the space of vulnerability assessment, because we should be careful or make sure that the cloud service providers' terms of service or terms of use allows for the types of VA that you would want to do or pen tests you want to do and at what frequency. So that should be contractually agreed. I think the rest is self-explanatory there. So this is the honeypot, we talked about it. Customer management console is one of the, another area which needs to be secured and restricted. These are some of the controls which is talked about on how to enable that. There's a long list of operational controls and standards. I mean, obviously we won't go through it, but the CCSP talks about all of this in much detail. So that's the reason why it is actually it's actually a lengthy domain, and many references to one second. Okay. So there are many references to best practices and standards, like it talks about ISO 27000. It talks about AICPA, SOC 2, It talks about NIST risk management framework in context of information security management. So yeah, I mean, I won't go through it, but just to let you know, all these are aspects of cloud operations and therefore covered in this domain as well. Then finally, we go to digital forensics challenges in cloud. So e-discovery, I think, is a concept that we probably all know, is this, which is the steps which include the identification, collection, preservation, analysis, and review of electronic information in a digital environment. And within the concept of e-forensics or e-discovery, really, the challenges in cloud are the high availability and data replication, which complicates the identification of a single crime scene, because the data is replicated by design in the cloud to just enable high availability. And if data is replicated, imagine zeroing in on the scope of this investigation, because there is no single point or a single location or a single server which is in scope. So that's one challenge. Multi-tenant model leads to more suspects, because if something is happening at the hypervisor layer and below, there are more suspects involved because there are many more actors in the environment that needs to be ruled out. And shared responsibility makes investigation, collection, and preservation more difficult, right? Because you need to coordinate with the cloud service provider as well, who will not be by default giving you through and through access to everything. So contractually, you need to agree on what are the roles and responsibilities during digital forensics or e-discovery as such. It talks about two important standards, which is reference one is 27050, and then CSA security guidelines, domain 3, which talks about contracts, electronic discovery. Those are some references that are made in the CCSP, which I believe you might want to glance through when you prepare for it. Then legal hold. In your own environment, when there's a legal hold issue, it's easy for you to practice it because it's all in your control. Again, from a cloud service provider standpoint, you need to have provisions that when a legal hold is enforced, there is provision made for the storage of that information, handling procedures that needs to be in place, what SLAs the CSP should be binded to, etc., should be called out. As I said earlier, contracting is one of the most powerful tools when you are getting into CSP, and within the space of e-discovery and digital forensics is even more prominent. And then I think some of the best practices that a practitioner should follow when at the beginning, before a forensic expert is brought in, is all that is mentioned, because logging, document everything, because you need to show that the evidence has not been tampered with. Handling volatile data, especially that data that resides in your RAM and memory. How do you deal with that? Work on copies of data wherever possible so that the source original data is always left intact, and always verify the integrity as often as possible and follow standard procedures. Some of the best practices which apply everywhere. It just gets complicated when you have too many cooks in the kitchen here, which is basically a CSP, other tenants, yourself, trying to get this worked out, and therefore that entire roles and responsibilities of this process should be highlighted via the contractual terms and agreements. So we can move on. I think we'll try to wrap up a bit this section so that we can do again some questions. I think I covered some of these aspects already, just give you an awareness of it. I mean, I was talking in the beginning, some of the parties or stakeholders you should be aware of when doing, when working in the cloud and running security operations. There are vendors, there are customers, the shared responsibility model also needs to be communicated in terms of who, what, why, and when between the CSP and the customer, the partners, the regulator. There are other stakeholders like the public at large. You need to inform them if you are, let's say, a publicly listed company and you're bounded by or binded by certain regulatory requirements. There are researchers, investors, and so many more. SOC is probably one of the last sections here. I won't go through it much because if you look at it, it talks about, again, the role of SOC, how monitoring is important for SOC, SIM and log management, and some of the best practices there, which is, I would say, broadly standard across. Incident management is introduced here. But I think before I get into questions, the NIST 861, which is incident handling guide, I think is something that would be helpful to look at because it gives the entire incident management life cycle, what steps are involved during the life cycle of the incident, which is again what is reiterated in largely the incident management section of this domain. So now let's do some questions. I think that would be the fun part. If you could log in again to the portal using the QR and the link, we can go through these questions to see what we can do. All right, so I have activated it. This is the link to go there. And once you're there, let's go through the question. What is the primary incident response goal? Let me know if you are not able to reach there, or I'm keeping this slide here so that you can log in.
Anurag, I'm not sure whether you saw this question from Udit.
No,
there are two questions he's talking about. Shall we take it up after you run through these questions before the break or after we come back from the break?
Yeah, we can do that. I will have a look at it and we can cover it after the break as well.
Awesome. So we'll do it after the break.
Yeah, we'll break in about 15 minutes and then once.
Yeah. Sure thing. Sure. Thank you.
Okay, so I've started seeing responses here. So let me move. I think this is a very important, and I was stumped by it as well when I did, and therefore I made sure this is called here, this particular question. So incident response goal, what is the primary goal of incident response? It's outcomes dictated by business requirements. So I think it's easy to get and choose some of the question or responses that you have chosen, which makes, I could imagine why you chose that. But this is where the CCSP way of thinking comes into play, and ISC square way of thinking comes into play. So different industries and different organizations will have different goals, and each organization will determine for itself what the primary goal of incident response will be. And this may even differ from incident to incident, depending on the nature of the incident itself. So it's a much broader catch than being very specific and saying incident response should always be to revert to the last known good state. That's not a mandate, right? I mean, business ultimately is the business requirements that dictates what incident response goal should be, the primary goal should be. So debatable, but yeah, I mean, gives you an idea of how they want you to think. So this one is, again, I don't know if there is a science to it, but you just, if you know it, otherwise you don't. You are in charge of building a cloud data center, which raised flow level is sufficient to meet standard requirements. Okay, so this is where I was saying in the beginning, do try and go through some of the data center physical, excuse me, design specific references. The CBK does not cover it uh, in detail, to this level of detail actually. So it might be good to look at some of the references that the CBK makes to understand some of these answers. So here the correct answer really is 2 feet, which is essentially 24 inches, which is the right answer uh, for the raised floor level. All right, let me move to the next one. Okay, so again, continuing on that, what purpose does the raised floor serve? So if you don't know the answer as such, you should try and play with, excluding those answers which you think doesn't make sense here, and then arrive at something that might be the right answer. So in this case, what purpose of the raised floor serve is actually, yeah, I think what you have there is the right answer, which is the cold air feed in place to run wires for the machines. Correct. All right, you are in charge of the data center. Which of the following is a useful rack configuration for regulating airflow? Airflow. So I think with common sense also, you might be able to understand this even if you've not gone through the design references. What would be the best um, rack configuration for regulating airflow? The choices there? No answers yet? Okay, so let me give the answer here. It's essentially, oh, we got one. So, so exhaust fans on racks facing exhaust fans on other racks. So that is called as the cold aisle containment, which is essentially also probably, if you think about it, is the best rack configuration so that the hot air from both the exhausts are coming in a single aisle, and that gets blown out as such. And to further, okay, so moving from that data center physical aspects to this one, uh, because most cloud environments rely heavily on virtualization, it is important to lock down or harden the virtualization software. Which of the following is not an element of hardening software? I mean, some of the questions when you read, and this has been something I would share. Uh, Sorry for the background noise there. That when you read a question, you will see there's a lot of distractions that would be there as well. I mean, you would have to read all the entire question, but not all parts of the question may be important to the question being asked, right? And sometimes it is as well, but you just have to, um, you should be aware that there are certain things put in the question which may not be relevant to the choice you make. Okay, so this one is correct. It's maintaining a strict license catalog, which most of you have answered. Everything else is part of hardening software. Licensing catalog is not about the configuration of the software itself. That's why it's not the right answer. That's why it's not part of hardening software. Okay. So which of these of a virtualized network adds risk to the cloud environment? Service. Okay. So this one is a tricky one. Let me show the answer first. It's scalability, because you see the question is asking about virtualized network, right? So when you talk about virtualized network, you have virtual switches which are used in virtual networks. And with what we mean by scalability here is that virtual switches can be connected to multiple virtual machines via a single cable. And if a cable is lost in a virtualized environment, these can affect tens or multiple devices. So scalability also comes with risks. It's very much similar to the question on DDoS that we had, where the magnitude of a DDoS is much more in the cloud environment. Scalability in cloud also leads to a wider risk impact, because a single component or there are many virtual components running on single physical components, and that's where the risk magnifies more. Okay, so let's move to the next one. In order to enhance the virtual environment isolation and security, a best practice is to do what? So if you might, okay, I've seen answers. So if you're not sure, try and exclude the answers which you think are just not, does not sound correct, because they're just not feasible. Okay, so the answer here is the second choice, which is majority what have answered. So you need to ensure that the management systems connect to a different physical network than the production system, so that there is this segregation, because obviously the management systems are more, I would say, more critical, because they would be essentially driving many of the configuration and management activities on the rest of the production environment. So having that segregation between the production management systems would be a best practice, not just in cloud. I think it's common in on-prem setups as well. You would have different network systems or isolation for different purposes. All right, so the next one is symmetric encryption involves what? So if symmetric encryption, well, this might be interesting for those who have also read encryption. So the right answer is passing keys out of band, because symmetric encryption involves the same key on both the sides. So how do you make that, or how do you distribute those keys are essentially um, important that it should be out of band. The Diffie-Hellman key exchange, rather, that was chosen is also a way of doing it, but it's used within the asymmetric encryption process where you are trying to set up a session key. So when you're trying to set up a session key, this is used in like your SSL handshake where you have public key and private key. And for a session, you use Diffie-Hellman to exchange the session key. But it's not the something that is used for in symmetric encryption as such. Symmetric encryption at large, basically the right answer, which will be true always, is that you pass keys out of band. All right, so maybe the second last question. Which of the following is a risk that stems from virtualized environment? Yeah. All right. So I think, yeah, that's the correct answer. Live virtual machines in the production environment are moved from one host to another in the clear because, and this comes in the context of uh, whenever there is a maintenance mode in place where the VMs have to be moved from one physical hardware to another because it's going through a maintenance, and the cost of encrypting all those virtual machines and moving them is too high. So usually those movements happen unencrypted. And if there's somebody who is able to monitor the VM movements across the network, can actually misuse that data, or rather at least have access to that data. So that is something that goes into the details. I think other are not really cloud specific risks so much. Cloud data centers can become a single point of failure. Not necessarily. It's actually something that you have ways to overcome, or rather in some cases it's actually not true that it's a single point of failure. I think the other two options just don't make sense. So even from that aspect, this is the most, I think the most logical response. So now we have the last question for this domain, which is the NIST RMF is required for federal agencies in the United States, which are the following is not a characteristic of the risk management framework. So if you've tried NIST RMF, you should be able to get this. Okay, so I think the answer here is actually the third one, which is, so it's the question is which of the following is not a characteristic of the RMF. So it says based on cost metrics and perceived threat. The risk management framework is not based on cost metrics and perceived threats. It is based on perceived risks as opposed to threats. So, but again, there's no cost metrics involved within the risk management framework. Everything else is something that the risk management framework touches upon. So with that, I would, it's 3:15 almost. So I think I will break for about 15 minutes and then we'll circle back at about 3:30. And then we'll have the last domain covered, which is about privacy and legal issues in the cloud. Then we should be able to have gone through all the domains within the CCSP. So with that, let me
Have ping yourself. Remove the ping.
So are you saying something, Suji? So we'll be back at 3:15. I'll just set up the announcement here.